afternoon to all guests. I'm Angela from Kotra, London. First and foremost, I would like to extend a very warm welcome to the South Korea Smart and Green Construction Business Networking event today. From myself and those who were involved in organizing this event, thank you very much to everyone here for allocating time to attend. This event is organized by Kotra London, Korea Trade Investment Promotion Agency, partnering with Construction-Vision-Forum CPF, who promotes and represents Korea's construction industry, and lastly, Department for Business and Trade, so formerly known as Department for International Trade, DIT. I will start with a quick run-through of the day. Tim Yeo, Honorary Ambassador of Foreign Investment Promotion at Kotra, will make a welcoming remarks followed by presentation to provide business opportunities and benefits in South Korea. Now, I would like to ask Mr. Tim Yeo, Honorary Ambassador of Foreign Investment Promotion and Honorary Professor at the Bartlett School of Sustainable Construction, for the welcoming remarks. Tim Yeo.
Thank you very much, and good afternoon, and a very warm welcome to our event this afternoon. I'm Tim Yeo, as you already know, and I am the Honorary United Kingdom Ambassador of Foreign Investment Promotion for South Korea. Since 2016, in that role, I've had the great pleasure of working very closely with the brilliant team in the London office of KOTRA, the South Korean Trade and Investment Promotion Agency. So I should say several members of the team, of course, are here today, including the Director General, and there'll be opportunities to talk to them in the course of the afternoon. The construction industry is a very big part of every country's national economy. And in a few minutes, we'll hear about the latest trends in the South Korean construction industry. As we all know, the built environment is a huge emitter of carbon dioxide. So together with the construction industry, it has a very substantial impact on climate change. Cutting CO2 emissions is becoming more and more urgent to help the world reach net zero by 2050. The target that we must meet if we're going to prevent climate change from becoming irreversible. And one important way to cut those carbon emissions is to adopt smart construction industry practices. And I'm glad we're going to hear a bit more about those during the course of this meeting. In fact, the subjects we're going to talk about in the next hour or so are actually extremely topical and important. But before we move on to them, I just want to say a quick word about South Korea itself. Because South Korea is not even now as well known as I believe it should be here in the UK. I've certainly learned a lot in the 6 years I've been involved with KOTRA, and I did know a bit before I took that role on. South Korea has the best record in the world for successful innovation. Its willingness and its ability to identify and then adopt the most innovative and high-tech solutions to every challenge, whether that's a technology challenge, an environmental challenge, a business challenge, South Korea often leads the way in addressing and overcoming these challenges because of its willingness to innovate. In addition to those achievements, South Korea also has the best educated workforce in the world. I've spent more than half a century working in government, in politics, in business, in civil society. And from all that experience, I have learned, firstly, I should say, in response to what was on the screen just now, that Busan is absolutely the right place to host Expo 2030. But I also know that all those strengths that South Korea has make it a particularly attractive place for foreign companies to do business and to invest. And we'll hear more about the support that's available for anyone thinking of starting to do business in South Korea from Koktra at the end of this session. Anyway, there are more important and better informed people than me to talk about the issues which are on our agenda. So I'll just reiterate, it's great to see you all here. I hope to meet each of you before we finish the afternoon. There'll be time for a networking session. Thank you very much indeed.
Good afternoon. My name is Yong Han An. I'm a professor at Hanyang University in Department of Architecture and Architecture Engineering. Today, I'm going to talk about some of the smart city strategies in South Korea. At the same time, I'm going to talk about a little bit about carbon emission reduction and green building strategies in South Korea. At the end of the slide, there is a big issue in South Korea for off-site construction. We believe that there are huge opportunities to solve our labor shortage and other issues using some manufacturing technologies into our building industry. So I will talk about why smart city and then Korea's strength and some of the Korea smart city development strategies. One of the big issues in every country, I believe that rapid urbanization and also there will be big social problems. We believe that everyone wants to stay in a big city, and because of that, urbanization rate is going up to 70%. Because of the big congestion, there are many different problems associated with these issues, such as traffic, housing shortage, probably London as well, or California, New York. Every country has a problem for affordable housing, and then pollution and other things. We need to think about how we can solve these problems issues. We believe that there are many different ways we can solve these problems, and one of the things is going to be innovative technologies. In South Korea, Professor Yo said that we are a very developing country. We believe that we love technologies. We try to find ways to solve many of the problems using technologies. Also, there will be one of the big areas will be fourth industrial revolution. And then using some of the data technologies, also we try to develop some of the governance structure to solve our current issues associated with many different things. So what is the smart city? In this smart city, it's going to be different for different locations, different countries, different cities. There will be various options and technologies actually we can implement in different locations. It will be different for London, different for Korea or a small city. From that, we can see many different things we can focus on. One of the big things will be public transportation. Probably I came here, it's first time to be in London, but transportation in public traffic jam and other things, in here something problem. So many of the people want to have a more good public transportation, and then we can think of how we can implement better public transportation. It's going to be a big issue in city like London or Seoul and others. Also, there will be some of the things, traffic monitoring management. The water will be one of the issues because of sea level rise or some other thing. And then safety is going to be a big thing. So because of the Korean government invests a lot of more videos, surveillance analytics, or some other areas we may focus. This is to show, some of the case why some city will focus for the smart city. So our idea of smart city is going to be how we can, using technology and some of the innovation, so we can improve our quality of citizens' life. Also, we want to make a more platform for new industry. We believe that we can create some other new industry implementing smart city approach for the cities. Also, one of the big things will be sustainability. How we can reduce energy consumption, how we can reserve our resource, how we can reduce waste. The other thing will be all of the governance. We have to persuade people to implement, or we need to adopt all different approach will help our citizens. Because of that, how we can set up the governance is going to be one of the big areas for smart city, because there will be some additional investment or taxpayers' money. We believe that the money or management will make something happen. Here are some of the Korea, how we can do it for smart city. The Korea's strength in developing smart city can be explained two ways. The first, Korea is smart. Korea has world-class ICT technology. And then also we are IT-friendly countries. Because of that, also we have a lot of good education, people, and because of that we want to combine some of the smart technology with smart people. That's what we want. But still long way to go. We are trying for that. So because of that, this is that we look at many of the smart technology strategies, options, with some of our good citizens with high education. The second is going to be, we are going to focus for more urban development. Because we have a short period of development. If you're thinking about 50 years ago in Korea, we are one of the poorest country in the world. But right now, we are, one of the developed country in many different areas. Because of that, we are still looking for two different urban development. One is going to be new city development, and the other thing will be how we can redevelop existing city that was developed and built about 40 to 50 years ago. At that time, we didn't have enough resource because of the structure is not that stable, so not durable. Because of that, we have to improve our current existing infrastructure and system that will support our citizens' need and other things. So here are our Korean government smart city policy. We set up, it starts not from smart city development. We have new city development or something, system development in long time ago, about 15 years ago. At that time, we are going to introduce some of the telecommunication technology into the city. That was a new city development. We got a few different experience in different way. And then from 2018, we changed it to the new city to smart city. So there will be, we adjust goal setting and information platform and system and other things. Also we change our target as well. So you can look at it. And here are some of the development strategy we are going to look at it. So if you look at this smart city, one of the main things we want to change people's life. We want to solve some of the issues associated with people and city. So number one vision is going to be how we can improve our quality of life. Yeah. So we can probably some of the urban problems such as air pollution and the energy issues and public transportation and environmental issues and other things. The second vision will be we want to embrace all citizens into this smart city process. What that means, we all want to make this smart city as one of the system, bring all citizens to set up the goal and make a governance to solve the problems, and then we can make a happy for everybody. So it's more for governance issue to make this smart city process. Also, we want to make a more innovative ecosystem. You know, we believe that sustainability, carbon reduction, waste reduction, and other things will be very important for our future generations. Because of that, you know, using this smart city approach, we can also integrate sustainability into smart city. We have many different process and implementation strategies and examples we did. But I'm going to introduce two of the new smart city project is driven by Korean government for new city development. One of them is the Sejong City Development, Smart City Development Project. It's our capital city in, capital city. It's a new city in Sejong. And we make one exemplary project in there. The other thing will be Busan, another exemplary smart city project. Also, we have a few many different small projects for existing city and other areas. Here are we can look at the Busan pilot project. We look at it, this is one of the sites in Busan. The land holding is by Korean Water Authority. So we are going to develop this city. So from here, we can look at many different areas we are going to focus, such as how we can make a more effective, efficient city administration, how we can bring robot or some other thing into our daily life. And then because of the near the sea area, we are focused waterfront development. We believe that education is going to be one of the key in South Korea. So how we can make a better education system for this exemplary Busan Smart City. And then mobility and safety and park is going to be 10 areas for the innovation for this Busan Eco-City Smart City. Here are some of the targets for this Busan Eco Delta Smart City. We believe that we are spending a lot of energy in our building sector to maintain high quality of life. Because of that, Korea does not have enough resource. We are import every resource from other countries. Because of that, how we can reduce energy consumption will be renewable energy source. So because of that, we put the target for energy consumption of city for 20% we can get our energy from renewable source. How we can make recycling 100%, and then because of the good transportation we believe that how we can provide better transportation system that will save our time for traffic and commute. Also, we believe that new job is going to be key for the smart city. Without job, nobody can stay in that areas. Because of that, how we can create job in that areas, so people cannot commute to other, neighbor big cities. So one of the key areas. So all different things. Also, we try to make a work and life balance. For my life, we spend too many hours for work. So I usually go to school around 5, 6 a.m. to stay school for 11 to 12 night. So that is my life. But I don't want my daughter and my son like that. I can work there. Yeah, so they don't want to be like this. So because of this national pilot smart city, we look at 3 different areas. We believe that one of the things will be process innovation. We go through every decision by this process, so we can improve, innovate our process for whole different decision making. Also, we are going to look at some of the technology innovation. Yeah, so how we can, managing the building, HVAC system will be more automatic, and then also we are going to use AI or some other deep learning technology to control the whole different system. Also, we can look at, loader building system, all different things. We try to make a more technology innovation. The other thing will be to do process innovation and technology innovation. We believe that this governance innovation is going to be one of the key to make technology innovation and process innovation, because we target for these 3 process innovation, technology innovation, and governance innovation for this smart city. So here are the core innovative factors. We look at many different things, but one thing will be energy, robot, and water. So energy will be, we want to make a more self-sufficient energy system for the area. Also, we want to make a more robot-friendly city, because we believe that, I don't know it's possible or not, but we try. There will be big opportunity for robot industry, because we do not have enough labor resource. So because of how we can integrate people and robot can make a more productivity growth, or we can make a more friendly between robot. And then because of the site, the Busan is near the sea area, so we look at the water specialized city. Here are some of the examples we did smart village for. This is the whole site area, but I'm going to talk about one thing for smart village. It's not very common in South Korea for residential building development, but we make an exemplary project for net zero energy housing project over there. So we can pilot and test, collect data, analyzing everything. Once we figure out the best practice, we can apply that approach to other areas. So we did for this pilot project in Busan. So here are something we can apply for this resident for that. There, you can see how they can do everything for daily life. And smart village, this is a living lab type, proof of concept complex. So from Mr. Kim is the famous surname. So what he or she can do every day is get up and what they can do. So that is the things we try to make an exemplary project. For the energy thing, we want to make a move for zero energy building for the system with some other new technologies. So we look at the passive technology and active technology. Also, we are going to increase a lot of AI technology to control the system. Also, we look at the personal mobility thing, smart lighting system. Also, there are intelligent CCTV system, and also we have some other, development, all different things. We make this exemplary project in here. Here are some of the things, additional one, water and environment. You guys can see, all different things we, implement in here to test, and we'll make sure that that will, one of the good strategy to implement other areas. So if you look at the transportation, also we put a lot of electric vehicle charger. Also we try to do shared car in the complex, how we can working the system or not. Also we can make call bus. So if we need public transportation, we can call and bus can come and transport to some of the areas. So we testing these things in that new developed area will make sure that the system is work, we can adjust and all different things before implementing other city areas. So energy thing will be big areas. So you can see we can use many of the BIPV or solar renewable system, hydrothermal and geothermal heat pump system. Also we can put the best passive technology. Also we look at the smart farm is going to be a big thing, how we can actually get a food from or himself. So we put the smart farm over there, so people can actually grow some vegetable in smart farm. Also, we love IoT things, so we look at some of the smart home IoT system to control every electronic devices and other things. So we want to make a more convenient building for that. In here, also we look at the healthcare, how we can make a better healthcare system. So we look at real-time healthcare or telecommunication system with a big hospital and local hospital. Also, we can see we can have an AI sports center, and then robot is going to be unmanned delivery service for the pilot project. How we can manage the robot and how we can control robot patrol and other things. Also living and environment, we can see smart pole, smart trash can, smart bench, smart signage, control center and other things. So we did. Yeah. Here are the second national pilot smart city project in Sejong. This is we look at very similar approach. This is in the middle of the country. We set up this smart city. This is the new city development as well. So in here we look at the 7 areas for innovation for this Sejong smart city. So one of the area will be mobility. Yeah. So one of the target is going to be how we can reduce number of cars down to 1/3. The healthcare, education and jobs. We believe that this education and job is going to be many times number 1 priority. Any city to survive extensively at this moment, but we are going to, the government spend a lot of money, a lot of investment for this new way of construction, and then some of the Korean construction company actually bought the modular manufacturers in the UK to make a good business in here, and the other companies try to buy some of the manufacturers in London, in UK area and other areas, because we want to believe that we can have a strong opportunity in this offsite construction or modular industry, because we have a really good manufacturing sector like LG, Hyundai, and Heavy Ship and other areas, because we can integrate that technology or manufacturing skill into our construction industry. We can make a leading country in the world. So that's it. If you have any question, let me know. Okay.
All right. Hello, everyone. Just to get a feel for the room, how many in the room recognize what this is? Show of hands. Okay. Some. All right. So this was written in 1998 in the UK by Sir Egan, which he later gave our industry, construction industry, 4 out of 10. And one of the criticisms was that if it wasn't such a slap in the face of the industry, it might have been adopted better or appreciated better. Well, I read it, and working in construction industry, it was a slap in the face, but I didn't enjoy it quite, but I found it quite appropriate. So this talk is about construction productivity, and we're going to use some of the lessons that I found in shipbuilding. So I believe in disruptive theory, coined by Clayton Christensen, and by definition, when disruption happens in our industry, I believe it won't be measured by percentages, but in multiples. So shipbuilding industry is much closer to AEC, civil, EPC than car manufacturing is, where a lot of the pinnacle of human production, Toyota production system, lean, Kanban, just in time, sprung from the motor industry, but where motor industry typically gets compared, we're like, well, they're too different from us. And shipbuilding is actually quite in the middle. They're closer to motor industry than we are, but they're actually quite closer to us as well. And shipbuilding is not new to, they had a share bit of disruptive innovation as well, disruptive cycles. So United Kingdom took over the world of shipbuilding, moving from timber-based to steels and rivets, and Japan took over by modularizing it and introducing welding. And we took over in the 90s and early 2000s by making the modules bigger, more complex, and we still are considered as number one leaders in the shipbuilding industry. So these are 4 elements that Rethinking Construction report reclassified the overall process of construction industry, and they called it complementary and interlocking elements. And if we arrange the 4 elements like this, where we've got partnering the supply chain all over the cycle, but it is the product development that's at the early stage that encourages production of components and implementation at the project level. So shipbuilding industry is ahead in some parts because they had a better ecosystem of what we see here. And we're going to understand this a bit further. So these are 2, let's say, masses, 2 different products, but similar mass, same height actually, exactly same height. And to the right, we've got a steel building that took about 3 to 4 years. It's 60-something floors, it's typical. And this ship gets manufactured or produced every 6 months. So you can see there's a huge difference, and it's not apples to apples. You know, they don't hire better talent than we do. They don't have better computers than we do. So why? It is a continuous improvement that is sprung from this ecosystem, which the AECON report also touched on. AECON report didn't just, slapped us on the face and you need to do better. They actually came up with a framework that we can do better continuously. 10% each year increase in construction productivity, less waste, reduces schedule continuously. So the shipbuilding industry had that flow, that feedback loop. If you are familiar with the network theory and system dynamics, much closer to the manufacturing industry than we have. So it is still being improved today, where they're trying to increase the size of the blocks from 100 tons all the way to 6,000 ton and above, and shortening the production cycle even further. In the 90s, there was a big push on transitioning from shipbuilding methodologies to ship production in terms of ideas, in terms of process, technology. So there was a lot of thought went into trying to catch up to the Japanese because ship production is really cutthroat. It underbids all the time. It's whoever bids the lowest wins. So that's right now it's Korea and China is almost on par in terms of the cost of a production of ships. So they really had to change the way they approached production to further reduce cost. So going back to first principles to really understand how they went about it, three elements of production is people, equipment, material, and how they look in linear system. We've got the process in the middle, consider that a job site or a factory, and material comes in and product is created or produced. Now, for a construction industry, it looks a little bit different, and this is, I think, where it differs mostly between manufacturing and ourselves. We've got multiple lines or multiple factories. Those could be prefabricated factories, pre-assembled factories, but that are off-site. And they get produced here, and the pre-assembled parts or assemblies will be shipped to job site and gets assembled there. Now it introduces two risk factors that are new, which didn't exist in the linear process. It's the logistics and assembly. So it's how we manage the logistics and assembly that can either make or break a production project or the cost. Now, interestingly enough, about 5-6 days ago, Tesla uploaded their YouTube video on Investor Day, and some of you guys are nodding. I'm guessing you guys saw it. So they also talked about this. This is the linear process, how it's typically a vehicle is made, and they're trying to move to parallel, pre-assembly, sub-assembly in the production design to increase productivity. So the idea is not new, right? They're calling it parallel and serial assembly. I coined the term parallel production. I said it's distributed and potentially concurrent. So same idea, right? Not much is new under the sun. So it looks like this, right? And like I said, logistics and assembly will be very different than what you see here than shipbuilding. So let's look at shipbuilding, because logistics and assembly, if you think about the connector types, the tolerance that they have to deal with, the ability to do precision engineering cut, to do right first time, it's very, very different. But shipbuilding, they're very akin to us. So shipbuilders manage the precision all the way from steel cutting down to small assembly, medium assembly, large assembly, and sometimes they put MEP in there. That was a huge innovation to pre-install MEP pipelines. And then it gets erected, brought into the dock, and it gets assembled. And you can't read the fine print in Korean here, but it says this is the secret sauce. Being able to perform right first time of a massive blocks to manage tolerances under 3 mil so that they can weld without adjustment. So dock is like an on-site, outside of dock is off-site. So you can do parallel distributed concurrent production outside of dock. Once it comes to the dock, it's got to be assembled, performed right first time. And that is what kept us ahead of the game and lowering the cost and being able to perform that incredibly tight schedule of 6 months of producing a ship. So we can agree on this formula that 10 times parallel process is 10 times faster compression minus logistics and assembly. Obviously the logistics and assembly is very different from manufacturing than construction, but as we saw from shipbuilding, that if shipbuilders did it, there's got to be something that we can learn from them. And today I'm going to talk about the assembly side of things. That's where our company specializes on. We've got about over 100 shipyards that use our product to manage dimensions throughout the life cycle of a shipyard production process. Right, so Rethinking Construction had this in consideration as well. So it talks about how we can unlock greater efficiency with precise engineering fit and right first time quality of product components. So they say it's a bit of a cliche, but we can't manage what we can't measure. And how we measure today to go towards right first time and precision cut and precision fit is measuring tapes. And as you can see from this smart AI, I thought it was quite funny. It talks about how I asked it what the measuring tape measures and the accuracy of it, and it said the accuracy can depend on the user's ability to maintain a straight line while taking the measurement, where the user is humans, right? So what's better than a measuring tape? Well, once again, first principles, it's point, right? Point before line. So if in a 3D Cartesian coordinate system you plot a point, you actually can get so much more than just a line, right? You can get dx, dy, dz, shortest distance, angles of all three planes, plus the parameters and the volumes of the cube that it may represent. So that's it. That's the secret sauce. Measuring 3D points, measuring 3D coordinates, rather than shortest distance between 2 points using measuring tape. How do we do it? Well, it's not new, right? The technology has been there. Plumb bob has been there since the Babylonian or the Greeks. Now, a little bit of a step up from plumb bob, I suppose, would be total station. But these are the targets that we're used to, right? Well, the shipbuilders use targets like this, which, if you guys are from, any one of you, if you have background in civil, you might find this quite interesting because you probably have never seen a target like this. Well, they don't sell them in typical survey stores. Neither Leica or Topcon or Sukiya or Trimble. You go to their catalog, it doesn't exist. But this enables users to quickly capture 3D points than your typical targets and prisms. So how are they using it? This is one of the jobs that our engineers are currently working on right now in Vietnam and Singapore, performing what the EPC industrial calls single weld hookup. So traditionally it was a double weld. You couldn't manage the measures so that they always accounted for a shorter puck piece in between and welded twice. Just like the typical modular projects in the UK, we make it a bit shorter and use shim plates to sort of align and make it fit. Now, I found this photo to be quite appropriate considering the weather that I experienced in the UK. But you can see laser scanning won't work in this environment, right? But here's the junior that's capturing and a senior that's holding the half target with the magnet attached. And the red point is just to illustrate the point that we don't shoot lasers all the time. But anyway, so measuring 3 points on a pipe gives you the center line which you can use to mark. And unless you understand the people process technology side of things, it doesn't really make sense how total station could be so fast. I mean, our engineers can capture about 100 points in 10-20 minutes, and it just blows your mind of what the traditional civil surveyors are used to. Total station is supposed to be slow, that's what I thought. So it can be slow, and it can be made easier, better, faster, cheaper, and that is the promise of technology, right? What used to be in the hands of the few can be democratized and belong to the hands of the many. All right, so these are some additional pictures of our senior engineer holding the targets. And being able to measure in 3D coordinate enabled South Korean shipbuilders to produce assemblies of 3,000, 4,000 tons and perform one-time setting. That is the term we use for right first time. Now, they do obviously adjust, but nothing is adjusted at the dock. It's adjusted before. And being able to plan ahead and perform adjustment ahead is key to performing one-time setting. So usually when we read reports like Rethinking Construction and a lot of strategies that we see in the world today, it's very top-down, right? And it's all great, whether we call it DFMA, prefab, MMC, pre-assembly, offsite. Those are all great, but what I found very interesting in the shipbuilding industry is that from the top-down, typical approach, how we're saying we need to develop products that request MMC, that request modular, that request prefabrication. But what you saw until now is actually the other way around. So I think it's a loop. This positive feedback loop works in both ways, where if you can perform one-time setting right first time, it enables you to implement it in project, it enables you to produce components of larger size, that in turn enables you to develop products with larger assemblies. So the typical process is planning, capturing, analyzing, creating reports, and this all is just very simple, measuring 3D. It enables you to plan ahead. So it doesn't just measure the single modules. We manage the entire chainage and it looks complicated, but like I said, the beginning is very humble. Just being able to use the technology that's available today. Hardware is getting really cheap. In China, you can buy totalizations for like a couple $1,000s. You know, it takes a matter of days to learn how to hold a target and how to shoot with totalization. So with a pair, it's very easy to start measuring 3D coordinates for precision, engineered fit, or right first time. So this is going to be the last portion. I'm going to speed up a little bit, but we say culture eats strategy for breakfast, right? Now, what culture would this bring? If it doesn't fit on site, we're going to expect a lot more rework. So that's the culture. We expect more rework, so we put more schedule as subcontractors, and as we put more schedule when we tender, it just adds to the cost and schedule, and obviously that added time to rework on site compared to off site. Scaffolding, equipments, you know, high works. So that's the culture. Now, what about the culture if it fits all the time? If right first time can be performed all the time, right? Then less rework is expected by the trades, and obviously we can reduce schedule. There's more time to more install and right first time, such that positive feedback loop at a task level for the right first time, and at a project level, you have more time to plan and prepare. There's risk management. We're spending less time there, able to plan ahead. 3-week look ahead is typical. Maybe we can look ahead further than 3 weeks in our industry. That obviously improves safety and quality, not to mention sustainability and carbon that follows, because there's very little waste with one-time setting. You're making all the adjustments off-site, not on-site, where all the right equipments and facilities can be incorporated into the factories for carbon emission reduction. Okay, the last is the supply chain. Obviously, by being able to perform one-time setting in the shipbuilding industry, there's more DFMA. Then if there's more design, more fabrication, improved cost and schedule, more demand, it enables the factories to invest more in expensive equipments, which in turn adds to the automation and lowers the cost and safer conditions for everyone. So we've done that in the shipbuilding industry. We applied the people process technology in one of the most demanding projects in Korea. That's about $100 billion of a compound, a Samsung semiconductor. In one of the water waste treatment buildings, we employed 7 shipbuilding engineers, 18 months. We performed 800 one-time setting on packages, pumps, spools, tanks, modules, pipe racks. And the average is about 70% reduction in typical scheduled time, apples to apples, from a previous water treatment facility of the eco design. So 70%, right? And it's just the beginning. So that was my talk on 3D coordinate, measuring in 3D. There's hardwares are there. It enables us to, by being able to handle the assembly side of things, it can allow us to plan ahead and be more aggressive with parallel production, rethinking construction from shipbuilding in South Korea. I'll be here until this weekend, so if you're interested to hear more about it, reach out. Thank you for attending.
Hello everyone, my name is Kim Chun. I'm happy to introduce about Edge AI in construction site. The presentation on Edge AI technology in construction site is very interesting topic. Let me start by explaining what Edge AI technology is and why it is necessary in construction site. This is me. I had worked for Samsung Semiconductors, so I know I have lots of experience with AI technology. Edge AI technology is one of the artificial intelligence technology that allows for real-time decision making by collecting and analyzing data on site. This is achieved by using machine learning and deep learning algorithms. Conceptually, Edge AI can be understood as the artificial intelligence that is located between, AI can be understood as the artificial intelligence that is located between cloud layer and IoT device. Let's take a moment to understand artificial intelligence in general. AI is generally classified into 4 categories: vision-based AI, conversational AI, analytical AI, and generative AI. Vision-based AI analyzes and processes visual data such as images, videos, and graphics. Conversational AI understands and processes conversation based on voice and text. Analytical AI analyzes data and makes predictions, like big data analysis, predictive modeling. Generative AI creates new content, like natural language generation, music generation, and drawing. However, this classification is non-regulation or standard, so there may be other classification methods as well. Let's discuss the role of edge AI in manufacturing industry, whether it can solve repetitive problems on construction site. In the manufacturing industry, IoT sensors are attached to equipment. In the past, the decision maker used their experience to make a judgment when problem arose. However, now they are creating systems that well-trained AI models can analyze and predict based on data and automatically implement them. Why was edge AI technology necessary in the manufacturing industry? It's simple, due to reasons such as the security of a company's manufacturing technology, real-time data processing, cost savings, and risk management. Question: where can edge AI technology be applied in construction site? In construction site, a lot of resources are being invested to solve problems such as safety management, efficiency, and budget management. These problems can be easily solved by applying edge AI technology. For example, during the construction of a typical structure and facilities, tasks such as welding and fencing are performed. Then, the quality manager will double-check the construction result of regular intervals. After that, they can move on to the next task by checking that the quality inspection for the construction in that area has been completed on system. There is a notable case here. A Korean construction company has developed and operates a remote inspection system for welding. When the worker takes a picture, the image is transferred to cloud for supervisor to read. Depending on the type of a problem, it's classified as a minor defect or major defect. And then additionally on-site inspection or follow-up procedures such as rework are carried out according to quality control standards. One interesting fact is that within a radius of 100 kilometers, there are 60 external shops where 200 welders weld 24 times a day. So 4,800 images are uploaded every day. In Korea, supervisors work for 8 hours, so they have to review and register the inspection result of all images within 1 day. To increase accuracy, if 10 supervisors are hired, they only need to inspect 1 image per minute. Now, let's summarize the efficiency aspect of digitalization using HAI. I will introduce the task of data analysis, which is considered the best job for AI. Step 1. First, I apply vision-based AI. After collecting, refining, and classifying welding type-specific trained images. After I'll choose the RCNA model and train it using supervised learning. Once the model is corrected, I will implement a web service through a REST API. Then, just like checking the weather, when the welder finishes the welding bit, they provide the welding bit image to the HAI server, and AI will respond with the result within seconds. Now I create and distribute an app and make it easy to upload the data using smartphone camera. The supervisor receives image judged by the vision-based AI as a significant defect and external shop information, and goes out for inspection and takes measures according to the inspection plan. Just one supervisor can solve this problem more easily and accurately than before. This is a representative case in Korea, and we are creating this AI service with Hami Global. Yeah, this is the images. We create 8 external bits and 7 internal bits, like that. What are the advantages and disadvantages of HAI technology? HAI technology can process data in real time and make quick decisions. Additionally, since it collects and analyzes data on site, it can reduce unnecessary data transfers. However, like any technology, if the stakeholders, such as workers and supervisors, do not pay enough attention during the data collection stage, the accuracy of HAI technology can suffer. Even construction experts who develop AI models with us, such as supervisors, often express negative opinion. The reason is simple. They are afraid that AI will replace their jobs. I also ask this question to dispel misconception about AI. When medical AI is introduced, which profession, nurse or doctor, is more likely to be replaced or disappear in hospital? This story has been uploaded to YouTube as well. Most people think it is nurse, but in reality, doctors are more likely to be replaced. No matter how much AI develops, tasks such as finding a person's vein and administering injection or dealing with people will not disappear. Instead, AI is more likely to assist in nursing tasks. On the other hand, there is a high possibility that doctors who analyze patient test results will be replaced by AI. As AI technology serves as a bridge between design and construction. Design is our plan, and construction is the result. If AI works well with drone, camera, 3D scanning, AR, VR technologies, it can digitalize construction results and offer new solutions that humans cannot perceive in terms of safety, cost, quality, and delivery. Finally, our topic is about how AI can play a role in digitalizing construction sites. Using AI, device can make quick and efficient decisions, providing users with a better experience. Therefore, AI involving technology to provide various services that people need to their daily lives, contributing to improving their quality of life. Thank you.